I think every single day we make the process better. And if you ask me a year from now, I'll tell you that the motor I built a year from now is better than the motor we built today. Oh, and that's been going on for 27 years.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Tom Nelson from Nelson Race Engines. Even if you haven't heard of the name Nelson Race Engines or NRE before, if you've watched the Fast and the Furious franchise, chances are you've seen some of his handiwork, in particular the 68 Dodge Charger nicknamed Maximus that Dom Toretto drove in the Fast and Furious 7. Now, that is powered by a twin-turbo 2,200 horsepower 9.4 litre Hemi V8. And this is the sort of work that Tom is best known for. He was a very early adopter of moving from superchargers, which were always synonymous with V8 engines, to twin turbos. And in this episode, we talked to him about why he went this direction, how it advanced the game for him in terms of how much power his engine packages were producing. And he was also one of the instigators of the mirror turbo setups that are now relatively achievable or accessible through a number of aftermarket suppliers. At the time, he was really pioneering this technique of mirror image turbos so that when you're looking into the engine bay, everything is nice and symmetrical. You might be thinking, well, why does that even matter? But when you're building cars at this level with customers spending between $500,000 and $1 million on a build, every little detail matters. So really interesting chat with Tom. We also dive into the business aspect of what he's doing these days and how the business has developed. Before we get into our interview with Tom, for those who are fresh to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune performance engines, how to build performance engines, how to create wiring harnesses, as well as race driver education, race car setup, and data analysis, just to name a few of our topics. Really relevant to our conversation with Tom today is our suite of engine building courses. And if you want to expand your own knowledge and learn how to build engines, this is the best place to start. We start here with our Engine Building Fundamentals course, which will teach you, as its name implies, the fundamentals behind engine building. You'll learn how the engine works, how the different engine styles operate, all of the internal components that are included in an engine and how they interact together. You'll learn the common machining processes that are required when building a performance engine. You'll learn about the tolerances and clearances inside our engines and how we may need to modify these from a factory specification when we are building something that's producing perhaps 2 or 3 times the factory power and revving further. Moving on from this, we have our practical engine building course, which dives a little bit deeper and shows you the step-by-step process to building a performance engine, irrespective of the platform you're personally interested in. Maybe it's a Hemi V8 like the one in the NRE Maximus, maybe it's an LS, maybe it's a 4-cylinder Honda. It does not matter. We know that when it comes to building your first engine, it can be a little bit daunting knowing what to do first and what order to progress in. And that's why we've created the HPA 10-step process. By following that step-by-step process, each of the individual steps is relatively quick and easy to complete. In the end, you've got a completely built engine. You're going to have the confidence that every clearance inside the engine is correct for your application. You're going to know that when it comes time to start that engine, it's going to perform exactly how it should, producing great torque, great power, and most importantly, great reliability. At the end of this course, we do include a library of worked examples, which is an informal walkthrough of that 10-step process. You can watch it being applied in real time on a range of different engines to expand your knowledge. We'll put links to those 2 courses in the show notes if you are interested in checking them out. As a podcast listener, you can also use the coupon code podcast75. That'll get you $75 off the purchase of your very first HPA course. Again, there's a link in the description. All right, with our introduction out of the way, let's jump into our interview now. All right, welcome to the podcast, Tom. Thanks for joining us today. And as we usually do, I want to learn a little bit about your background and how you first got involved in cars and the automotive industry.
So, my dad was into into hot rods. So he had like a 351 Mustang with a Boss in it. They had the Cleveland style head, and then he had a Mario Andretti series Lotus, and then he ended up twin turbocharging a Pantera. So we used to go to like the SCCA events with him and go to the track with him all the time. So he kind of, I don't know, he probably sparked it for me there, And we started out. I started my own auto detailing business with a go-kart that I had. I used to go around to my neighbors, drive around like a 3-mile radius in my go-kart with the vacuums and all this other shit, and detail all these people's cars.
What sort of age are we talking here?
13.
So the entrepreneurial spirit started pretty early as well.
Yeah. And so then I guess from there we started street racing. So we'd do street racing, and we were doing it, 3 nights a week. And, we were actually, back then it seemed like big money, and we were doing a bunch of betting and stuff like that. And then the street racing got weird. There were gangs got involved and saw some bad stuff happen. Someone saw a guy get run over, another guy get shot over an argument. And that was it for me on the street racing deal there. The scene was weird. So then I decided, I'd love to start just doing this professionally, because I was a house painter at the time. Actually, I had like a construction style business. My mom was a apartment complex manager. So she managed all sorts of these different apartment complexes, and I'd be building fences or whatever they needed for all these things, and I hated it. So I decided, I'd like to start building engines. So I started doing all my buddies' engines on the side. My grandmother gave me her garage. I converted the garage into like a little mini engine building shop. My good buddy Cole Balster, who kind of was racing with us all the time, his dad used to like give away these body in white cars for pro stock racers. So one of the pro stock racers approached his dad and said, "Do you know anybody who's interested in buying a machine shop?" Because their cousin Bill Hyatt had recently passed away, and they had this machine shop. And his dad was like, "Yeah, well, my son's good friend is building a machine shop right now, so he'd be interested." And when I walked in, it was like amazing. I mean, it had a go powered dyno and the flow bench I still use today, and all this machinery. And it was like, this is what I wanted. I didn't have enough money for it, so I ended up bidding this huge fence contract in the middle of summer. It was like 115 degrees out, and it was like kind of a race to the finish to get this machine shop. So I think we built 100 fences in like a month and a half, and my grandmother loaned me some money, and between those two things I was able to purchase the machine shop. And that's how it started. We just, in 95, we opened the doors.
All right. Well, let's rewind a little bit, because there's a pretty different skill set between building fences and painting houses and building precision race engines. So I'm going to guess when you said that you're involved in the street racing scene, at that point, you're building up some level of mechanical skill, either building your own engines at that point, or at least spinning spanners on your own car. So is this all self-taught, including the engine building element, or were you going through some formal qualifications previously as well?
Yeah, no, it was all shade tree stuff. I mean, I don't know if you remember this, but back in the day, we'd like, underneath my bed was like a mecca of like there wasn't the internet. You had magazines. You'd be like, "I remember when this guy built this motor," and you'd thrash through hundreds of magazines to try to find that one article or whatever. So we were just trying stuff that, monkey see, monkey do. And, I think at that time I had a 85 IROC Z that I had bought that was like a total piece of shit, and it always broke. So that kind of sparked everything. So I ported the heads and made my own cold air intake from like Plumbing City store stuff, made a homemade nitrous system on it. And, it snowballed into kind of what it is today. That's kind of how it went.
Yeah, absolutely no difference into the direction or path that I tended to take, although I didn't obviously go as deep as you've gone in the engine building world. In terms of that, obviously there are formal qualification paths you can take if you want to become an engine builder, or I probably more refer to them as engine reconditioners. And this isn't to get offside with engine reconditioners, but I do see a bit of a disconnect between what your average engine machine shop does or engine reconditioner does and the likes of what you're doing. And why I say that is most engine shops are probably rebuilding sort of your garden variety, low horsepower street engines where the tolerances aren't probably quite so critical. When you're trying to build a 2000 horsepower twin turbo V8, you're kind of working to a different level. So where I'm going with this is, coming from a traditional background of learning the skills of engine building, does that set someone up in and of themselves to then go and build a 2000 horsepower twin turbo V8? Or is there a different level of understanding, knowledge, and skills that are required to operate at that level?
I don't come from a background of like schooling or engineering. I come from a background of like shade tree, try it, see how it works, and then see what didn't work and make it better. So yeah, I'm not saying like we're the mecca here and we know what we're doing. I think every single day we make the process better. And if you ask me a year from now, I'll tell you that the motor I built a year from now is better than the motor we built today. Oh, and that's been going on for 27 years, so we constantly are evolving the process and making it better. And the sad thing is, if you bring me a stock motor to rebuild, I'm still going to build it at the same level, clearance wise and quality wise, that I will the 2000 horse motor. It's just the component selection and stuff like that will be different. But as far as like, the pride that we take when we're machining stuff, we're going to do it nice any which way, or else I don't want to do it. It's a waste of time for me if I'm not going to take pride in it.
Sure. I think what you mentioned there about just seeing the evolution of what you're doing and learning from what you see come back. I mean, I think that's really valuable. I had this a similar experience with, back in my drag racing days, and I'm sorry, we were 4 cylinders too short, but we were dealing with the Mitsubishi 4G63 engine, and we were building a number of these, and we were up around the 1,000 wheel horsepower, and we would get these engines back in at the end of a season, and you got the opportunity to go through the engine and see, how they'd worn, what was wearing, what was good, what was bad, and that iterative approach of seeing what came back after a season of racing and then making small iterative adjustments and then doing the same a season later. I think that really accelerates your learning. And I mean, you've got multiple data points on this, so I can only imagine that curve gets accelerated even further. In terms of the engine assembly process, that's one element. And I mean, we have courses that cover this. I genuinely believe that any enthusiast with an eye for detail and some patience can learn those skills, albeit there is a practical element. Obviously, you need to get competent with that. I sort of see engine machining, the actual machining processes, though, as being another level, and often that is something that most people would go through a training program for. So when you bought that machine shop, what was the learning curve for you like, getting your head around all of that equipment and getting the best out of it?
It was crazy when I got the machine shop because I had all these machines and I didn't know what I was doing. So I was just taking junk blocks and trying to learn the process. And I kind of thought I knew what I was doing. I had a guy come in that I traded use of the shop for him, kind of showing me the way. But there was actually an old gentleman that used to run a shop called Evans Speed Equipment. His name was Gene Oley. And so this guy was the guy in my dad's mags. He was like the guy, and we kind of struck up. I was selling a wet grinder that I didn't need in the shop. And he came by and was looking at a couple things and, in a very nice way could tell that I didn't know what the hell I was doing, And so kind of on the weekends, we would, we'd trade some things and then he would show me the proper way to do things. And so he set us up in the beginning and really put me on a different level than your average guy, because he had been doing this for his whole life. So all these processes that he knew, I think he enjoyed showing somebody that was into it, that appreciated listening to him on how he did it, So even today, like how we true our line hone in, how we true the rod hones in, there were all these really specialized old school ways of doing it. And today you can go get like a rod machine that has a power stroker and all of that stuff. And I can by hand beat that machine any day of the week just by setting up the stones correctly, you know. So it really has to do with the setup and the operation. And I was lucky enough to have a guy kind of put me on the right path. And then, you know, every month you're realizing that you can do it better. So that's kind of where we're at right now.
Yeah, you just raised an interesting point that I often sort of wonder about. I mean, these days, the advent of CNC machining equipment is obviously sort of taken over. And we see a lot of machine shops all around the world with the latest and greatest CNC equipment, which on one hand is great. These machines, when used properly, obviously can do an exceptional job. And then we've got older machinery that when you understand how to use it and the operator really knows their stuff, I would sort of see that they could probably arguably get comparable results to the CNC equipment. It sounds like you sort of tend to agree with that stance.
Well, I think the CNC equipment is just, it's faster, but it's definitely, I wouldn't say it's better because, like, for example, we get brand new blocks all the time that are cut on CNC equipment. And like, we always have to change the deck. You know, the deck's always crooked one way or another. The bores aren't perpendicular perfect. The honing, you know, I haven't really played around too much with the new computerized hones, but my hone, I have actually taken all the automatic feeds off and I actually use my hand to feel the cylinder, and the guys that I've taught how to do that, so I can load and unload the cylinder exactly where I want it with just finger pressure. So we'll hold a tenth up, down, bottom, side to side, and I'll be able to, you know, hear the cut. Is the cut bright? Is it gummed up? You know, all of these things when you're honing a cylinder, you're not going to be able to know any of that when the CNC machine is just doing its thing and you're walking around, you know, checking things. So I like that little intimate, especially because we don't do a lot of motors. We're only doing maybe 200 motors, 300 motors a year or something like that, you know? So, you know,
I'd argue that's a few.
yeah. Well, not. I mean, there's guys out there, you know, doing thousands of motors, right? So that's when you want to really get into, you know, a CNC where you're just, you know, you have to because, you know, either that or you're gonna like,
Efficiency of the time
yeah.
saved.
So I was honing, I was doing the cylinder hones and the machining for a while, and then, you know, it's a very special guy that you're gonna allow to do that for you on with your name behind it. So, you know, the guy who's doing them for me right now, I mean, it was probably 2 years of messing around before he really had the hone right, you know. And now, you know, we joke with each other because we punk, you know, oh, you know, I did a better job than you or whatever, and it's a little competition. It's nice though, you know.
Yeah, yeah. Nice to have a little bit of friendly rivalry. Just to dive into that, just in a little bit more detail, is that honing process is really critical. Obviously, it creates that crosshatch pattern, and the rings are going to bed against that. But the bit that's easy to overlook for those who haven't really been involved at any level is that you're also, depending on where the hone dwells and how you use it, it's very easy to create either taper or belling in the bores. In other words, you know, on face value, you'd think they're going to be perfectly round and perfectly parallel from the top to the bottom, but it's very easy to create a bore that isn't like that if you don't know what you're doing, correct?
Oh yeah, without a doubt. I mean, there's a certain stroke length and how much you're overstroking, where it's overstroking on the top or the bottom. All of that is crucial. And what not a lot of people realize is not every stone is the same. Like you could put in like a Sun 623 and be having a bad day with the hone, and just that batch of stone was just a bad batch of stone. Swap the stone out, and all of a sudden everything looks right to the world, you know. So we even have special stones that we've had made for difficult blocks where they're real soft and they break down fast. So sometimes you get like an old Donovan or something like that where it wants to be an egg, and you know, a hard stone just continues, it won't unegg the cylinder, where you can put, like, we call them these magic stones, and you can put them in there and you can actually hear them taking out the high and the low.
So is that down to sort of an uneven hardness in the factory bores that's causing that sort of, as you say, egg shape to occur?
I think there's so many variables. Like there's sleeves that come out of the bottom of the bore that are not supported. That can go weird. You know, when you plate some motors, they really twist up. So you You got to take this thing that was round and like, for example, like a 2.8 V6, not that we do those anymore, but back in the day, you could plate hone it, put the thing together. It wouldn't even turn over until you torqued the heads on it if you plate honed it right. So they were that much of a noodle, and then you torque the heads on it, thing rotates over beautifully.
Just shows how much distortion there is with the heads being bolted on.
Yeah, the new blocks are pretty good, but I mean, like for example, LSs, we're putting 105 foot-pounds on the head bolts. That can move a cylinder pretty easily. Although I will say, like the Dart blocks, the way they have it, they're pretty stout, so they don't move as much as like the old stuff. The old stuff was like an old FE Ford or something. Like you could I mean, those are the worst blocks in the world.
All right, Tom, let's find out a little bit more about Nelson Race Engines. Obviously, there's a big hint in the name there, but as I said, you do a lot more than just build race engines. So can you give us an idea of the scope of this business?
Up until this year, we basically were a one-stop shop. I mean, we would paint the car, could build the chassis, full, complete, top to bottom, R&D, prototype, make custom intakes, make custom exhaust conduits, even design complete engines from nothing. At the beginning of this year, I decided that we were going to basically not take any more cars, not for a while at least, because we had like 22 full builds going on and it was just taking too much of my time. So we've basically thinned out. I think we got 10 cars left and probably got about 4 years of building those 10 cars that are left. But we do all sorts of stuff. Like we 3D scan, we 3D print, we do all, SolidWorks design in-house. We've got 3 chassis tables, like this mid-engine all-wheel drive GTO we're building. We made the chassis, we made the suspension from scratch. We helped design the all-wheel drive system. So like our capabilities these days is just absolutely bananas comparative to really not many people know that we did that. A lot of people just think we're an engine shop, but yeah, we pretty much do it all.
How did you go from purchasing that engine shop and sort of bootstrapping that to sort of building up these capabilities? I mean, obviously, as you say, you've been operating for 27 years. These things don't happen overnight, but I mean that's a very big U-turn from just focusing on the engine machining at the start.
It started, probably, to be honest, the way it started out is in 98 to 2000, we were starting to do a lot of turbocharged, like 1,000 horsepower small blocks, which doesn't sound like anything today. It's like no big deal. But back then, nobody even believed it was true. But along with that came, like, you had to have a correct radiator, you had to have a correct cooling for your transmission, you had electronic fuel injection, you had to have fuel system to deal with all of that. The car needed to be caged. And so we would sell an engine to a guy and then spend so much time with support and everything because it was so new that we were teaching all these different builders how it needed to be done. And then at that point, I was like, well, we should just open up Nelson Supercars and start, building these cars. And so I bought a fabrication company, Red Zone Race Fabrication. And that's kind of what Nelson Supercars started is we, bought a buddy that used to do a lot of my fabrication. It was like, why don't you just buy my company? So we bought his company. And then along with that, he brought a lot of skills. And then we brought in a lot of talented guys on that end of the shop. And then started building these things out, bananas.
So at this point, as you say, you're sort of pulling back a little bit from the full custom builds. But at this point, how many staff have you got and what size is your facility?
There were 16,000 feet. And right now our staff, I don't even know anymore, but I think 14 guys. We're really a small shop. At one point we were at like 30 some odd guys when we really had the cars humping. But half my day was like HR problems and like figuring out every roadblock there is on custom cars and having to relay that back and forth with the customer. And it just got to a point where I wasn't enjoying myself as much. It was just too much to do. So that's kind of why we've pulled back away from that. I mean, I love the cars because the cars make my engine building packages so much better. Because when you get to put them in and drive them and understand how they work on the street and understand how they work at the track, it's not just like building them and sending them out the door. You get feedback.
Yeah.
Also, like the packages too. Like if you bought a package from me 10 years ago, it was a lot harder to put in than it is now, because now we've refined so many different processes that it makes the end user, a lot of times people get worn out just trying to do it. Back in the day, it was just, there wasn't a lot of fabricators around. There was, you know, they had to go through 10 different shops to get it done. Everybody's pointing the finger at each other. So we try to develop packages now that when you buy it, it's relatively hassle free. The headers fit the chassis, and the tune is all done for you. The wiring, you're just hooking up power and grounds. So it's pretty good now.
I'm interested in learning about the process of these builds, just because it sounds like a massive job. You sort of, I think you mentioned 4 years there to get the remaining 10 cars out the door. So, for a start, obviously it's going to depend on the quality and how extensive the build is. But I mean, on average, some of these full ground up builds, what's the time frame from start to finish?
Usually anywhere from like 3 to 5 years is what a build will take.
Okay. And over that time, could you estimate maybe how many man hours are going into them?
I don't really know man hours. On an average nowadays, like if you're gonna do, and this sounds totally crazy, and it even sounded crazy to me when I started, but if you wanted a car, like a nice car but still basic, it's about $500,000. You want a badass car, it's about $1 million. And that sounds nuts, but by the time you go and you fit the body and you block everything and you've custom made every damn bracket on that car, and you got that thing, at a pro level, even at that price, you look back and go, man, I didn't make anything on that damn car. And people will be like, you're out of your mind. But that's just kind of the way it is. Like, we'll spend 2 days on a bracket, and then you got 20 hours in a bracket, and you tell the guy, well, I'm going to charge you 20 man hours for this bracket. The guy wants to strangle you, but that's what it takes.
That's the reality.
Yeah.
It's good that you've brought that up, because I think those who haven't been involved at that level would have no understanding of how projects like that will just consume time like you wouldn't believe. Which was going to be my next question around, as a business, one of the problems, I never operated at the level you're operating at, but we would have customers come in and want to do a build on a car, and I mean, every time it's something different. So it's not like you can take the recipe of do this, this, and this, and it's going to take this many hours, and we charge this amount of money, and it's out the door. You're learning as you go, and you find other problems as you that you couldn't ever possibly predict as you progress through the project. So pricing those was very problematic, and to my mind, it still is, unless you're doing a rinse and repeat cookie cutter. This is a car I specialize in. We offer these parts. We fit those. You'll get this result, and it's going to be this much money. And that's definitely not what you're doing. So, I mean, how do you approach that side of things, or are you just dealing with the very few customers you're fortunate enough to have where the dollar value on it doesn't matter, and they'll just write the check at the end of it, and you charge out all of your hours? I'll add to that, because most shops probably end up, for every 100 hours they put into the job, they sort of look at it at the end and go, oh shit, I can't charge that. I mean, that seems excessive. So instead of charging 100 hours, a lot of shops will probably end up pulling that back to 70 hours, and then you're kind of just doing yourself out of a job, really.
Yeah.
What's your take on that?
Yeah. It's a crazy process, because what you're doing is you're creating a 101, right? And it's every single one that you build, nobody wants the same thing. Everybody wants something bigger, badder, different. When you do that, there's I was pricing stuff out. I'd be like, oh, we'll build this car for 350,000, and then we'd finish it. There was a lot of stress involved, because they're thinking, oh, you're taking so much time, it's so much money. And at the end of the day, we lost like $150,000. So we paid the guy $150,000 to build this car, and we did that almost on like every build up until the last few years. And it's just because I was taking it as like an art form. And I'm like, we've already taken this, and this to this point. I can't just go this far with that much rest of the car. And these guys that I got working on my shop, I mean, I'm headhunting these guys from all across the world. These guys that are working in my shop, these are the best guys in the world, right? So, and our labor rate is still $90 an hour, which is insane, right? So I got a guy that, is a natural talent that I'm hunting down to bring in my shop to work. And this guy is an absolute artist, like everybody in the shop. And then I'm worried about charging $90 an hour for this artist that's in my shop making gold, and the guy who's paying for it's going, I don't even understand. And I actually do understand where that person would be coming from. But after running a shop now for on the supercar side of things for over 16, 17 years, it just is what it is. You have a customer that wants to do it, or isn't worth your time, because it's just stress at that point, and I've built enough cars to not need to prove that we need to build another car, so that's kind of where we're at right now, and we're a bit overwhelmed with how many cars we got going on. But I bet you the story is probably the same on most builders if you talk to them.
Yeah, I think a lot of it comes down to educating the customer at the start of what the process is going to be, and even if you can say, just like you did at the start of this, a good car's $500,000, and if you want something super badass, then you're looking closer to $1 million. I mean, those are ballpark numbers. I mean, those are huge numbers, no doubt. But when you're looking at something bespoke with a 3 to 5 year build and the man hours that's going into it, I mean, unfortunately, that's kind of what you have to pay to play, and you're going to have something that is one-off and at a world class. So I kind of get it, even if my wallet won't quite stretch to that at this point anyway.
I mean, it's weird to even think of that, but that is the reality of it at the level that we're doing it,
Yeah. Interesting to talk about sort of some of the more popular US domestic market muscle cars that are popular for builds. Now there's a lot of companies, or a number of companies, that are offering sort of off-the-shelf full chassis for those. Is that something that's worth looking at, or everything you do is just 100% in-house?
Oh no, yeah. The chassis like Roadster Shop and Art Morrison, those guys are unbeatable for the value that you get. I mean, you're getting this really nice modern chassis that has good brakes, modern geometry suspension. You cannot touch that. Only time we're doing one-off chassis is for like the flagship cars for Nelson Racing, and even then, I'll have guys at Roadster Shop make us something. Those guys are amazing over there.
Yeah. All right, let's talk a little bit more about the engines. As I've sort of mentioned, that's probably one of the areas you're best known for, and more specifically around sort of monster power, 2,000 plus horsepower, twin turbo V8s. And the V8 market, as I've seen it sort of evolve, it has always been more geared towards the supercharger, and specifically initially roots and now screw blowers that sit nicely in the valley. I mean, it's a nice packaging exercise, and V8s and twin turbos for the longest time, they weren't a popular combination. So I'm interested to know why you sort of went that route rather than sticking to the superchargers that most people deal with.
Well, we started off in 95 and we got a good client that was doing a ton of offshore marine stuff. So we were doing a ton of 1471 dual dominator 572s. And, I mean, you look at that thing when you're done and it's like 10 feet tall. It's got a nasty cam and all this, it looks like it's going to make 5,000 horse, and they make like 1,000 horse, So I think we had done a ton of those, and then we swapped over and started doing some turbo stuff. And I used to call them a 2-for-1, because I mean, the turbos just murdered the blower motors as far as power goes. And also, like when I was a kid, my dad turbocharged his Pantera, and it was like I knew what the results were from doing that. So we started adapting all of that stuff into the street stuff. I still remember I had this manual Go Power dyno where you manually load the water brake, and it had a raw 750 foot-pound gauge, which that dyno was like the stingiest dyno. If you made 750 raw on that dyno back in the day, you were like the king, because it probably should have been, you could have equated that to like 1,100 foot-pounds or something, So we were working, trying all these different turbo combinations. And back when I started, everybody was T3, T4, these little baby turbos, and all the turbo experts were telling you, look at the compressor map, you shouldn't be running these big turbos. when you go to the track and you see race cars run, they were always running like a bigger turbo. And we spent like 9 months fucking around with these bullshit, hybrid small turbos on a V8. And at one point I was like, man, I don't even know how to build a motor. Like, we can't make over 700 horse with these turbo motors. Like, I started to think I didn't know what I was doing. And everybody's telling me, oh, you're not tuning it right. A header parameter diameter is not right. A camshaft's not right. And so I think we went through 26 different turbo sizes. I went through like 5 camshafts, 3 header sets. And then finally I was like, I'm done listening to all these guys. I'm going to spec a turbo that I want to run. And we spec this 72 millimeter turbo. And when we pulled the handle, I almost blew the intake off because it was so lean. And the smile on my face, I knew at that point that we were on the right track, because it was putting so much air in that motor, the tune-up just did not keep up. So we literally swapped from what was known at the time, this 60 mil turbo, to this 72, and picked up 550 horsepower, just a turbo change and putting fuel in it. And that thing took that took my old Go Power dyno, wrapped it all the way around 750, went up to like 300 foot-pounds on the other side. My eyeballs were like, oh my God, what the hell is going on here? And at that point, I'm like, all right, well, we got a combination for the street now that's pretty much unbeatable. And you're going to make 1,000 horsepower on pump gas on a street. Back then, it was like, forget about it. It's 20 years ago, over 20.
Obviously, as you go larger with the turbo sizing, it is a balance of airflow and high-end power versus response. But of course, when you're dealing with a reasonable capacity V8, you've got that capacity to your advantage. So you're still getting, I'm assuming, reasonable boost response, reasonable boost threshold with these turbos.
Yeah, well, that was the thing, is everybody's like, you got a drag race turbo, it'll never spool. And I think one of the cars, it was a 98 57 LS, where you had the turbos mounted low, and it was a stick car of all things. That thing light up like nobody's business with a 68 turbine with a 9.6 AR. You think, oh, it never turn on. And man, that thing would just, I remember we were going to Palmdale one time. My brother had a Viper. I walked away from him like he wasn't even on the throttle. It was so bad. Back then, like, it was like 140 mile an hour car and a quarter, but it was like, back then on 91 octane going 140, that was badass.
Yeah. One of the packaging problems, obviously, with turbocharging, when you're building an engine where the aesthetics are every bit as important as the power and torque that the thing makes, is traditional turbochargers are single rotation, or the direction of rotation is fixed. So it's hard to make the whole engine bay and assembly look symmetrical. Which, I mean, okay, does it matter? It really depends who you ask, I guess. But you were one of the first I saw were actually producing mirror image turbochargers, so you could get that symmetry. So what was the driver behind that? Was this just purely the aesthetics that made you go to that extreme?
Well, we were doing a ton of turbo stuff at that point, and I was so sick of like trying to, put the turbos at an angle, or trick your eyes into not make it look like it was unsymmetrical, that I decided I'm going to go ahead and make some symmetrical turbos. And so we actually patented the mirror image turbos. It took us 3 years to get a actually utility patent on it. And when we did that, it just, oh man, it made the installation so nice. And there's some advantages to mirror image turbos that people don't really think about, is that when the left side of the motor is operating the same as the right, your reliability goes up. So when you got a snail going the different direction on the left, then the header tubes are different, the intake conduit is different, the waste gating is different. So the mirror image turbos, they actually, in my mind, it's the only way to do it, really. Plus, it just drives me insane to go look at a car when they're not mirror image. That's obviously I got issues,
What you're saying there with the packaging, you're able to not only have a mirror image turbo that then by default allows you to essentially have mirror image of the exhaust manifolds, the wastegates, the wastegate placement. So essentially both turbos are getting fed in exactly the same way. There's no discrepancies in airflow. Is that sort of what you're referring to?
Yes.
Okay. Now, I'm guessing you sort of don't wake up one morning and go, hey, you know what? I'm just going to pop out the back and jump on the lathe and I'm going to spin up a turbocharger. There's quite a lot that goes on to that. So I'm assuming you'd sort of aligned yourself with an existing turbo manufacturer when you started down this path of the mirror image turbos. How did that all work out?
We actually kind of did it the way you said originally, is we actually drew it.
Okay.
And I mean, I was cutting exhaust turbines at a solid Inconel, and we'd go through like 2 bits per wheel. It'd take 15 hours to cut one turbine on a 5-axis. So we were doing that, and I was charging like $15,000 a turbo or something. And I'm like, well, this is no way to make money. But obviously I wanted to do it. And then I had a really good working relationship with a company called Turbonetics as the president of the company at the time, this guy, Brad Lewis. Me and him get along thick as thieves. We're real good friends. So I was like, can we, design this, and then you would manufacture it. So they would assemble it, balance it, package it, and then we would just sell it as an NRE turbo. And so we struck up that relationship, and it's been fantastic. Turbonetics bought Precision, which was owned by a company called Wabtec. So now Precision is actually manufacturing our turbochargers.
And now, obviously, we've seen other mainstream manufacturers jump on board with the mirror image turbos, the likes of Garrett, etc. So it's sort of, I don't know if you started that revolution. I mean, certainly you weren't the first to have a mirror image turbo, but at this level and at that size in particular. But yeah, now they are obviously a little bit more mainstream. Now, in terms of the rest of these packages, again, kind of following that same trend of the form versus function or the aesthetics of the finished package, I mean, there's a lot of detail that you go to with the likes of your billet inlet manifolds in terms of hidden fuel systems, hidden wiring. How do you sort of weigh up the balance between the aesthetics and the ability to easily and quickly work on aspects of the engine? How do you sort of make the decision of where the sweet spot is there?
One of our slogans is like, we build functional mechanical art. So I definitely look at our engine packages as art, not only as like a functional engine, but I look at it like a piece of art, like a little piece of jewelry that you picture frame in your engine bay. Obviously, if you're doing like drag week or a race car, you don't want hidden injectors that are going to take you 3 hours to take out and cuss while you're doing it all the time. And so there's a fine line between serviceability and beauty. There's always a compromise somewhere. So we have different packages that, like, we've got some really nice crate packages that are really easy to service. Everything is drive-by-wire throttle. Injectors are completely available to get to, harnessing everything. And then if you want to get like into where it looks like it doesn't even run, we go as far as hiding throttle linkage, hiding sensors, hiding injectors, looms, etc. And the customer can kind of decide that with us. So we have, from basic to Riddler style quality.
I'm assuming as well that some of the higher end builds that you're doing, these sort of $500,000 and up cars, they're not daily driven. They're probably not sort of doing 20,000 miles a year of commute, are they? They're sort of the odd weekend and probably not clocking up too many miles.
Yeah, when you get into a car build at that level, there's some guys that they have the money, they don't care, they're going to drive it. But sometimes the car gets so nice you almost paint yourself into a corner, and it becomes stressful to like leave it in the parking lot, and that becomes a negative at some point. So there's definitely, like a big kick right now is like the Survivor series that Jeremy over at the Roadster Shop is doing. So they'll find like a good car, it's got some patina, and they don't really even care about the outside, and then they put a chassis, brakes, engine, drivetrain all in it and make it all modern, and they can take it anywhere. Some guy scratches it, then it just adds to the character of the car. So there's something for everybody out there, right? There's also the show car guy that wants everything so immaculate that you just have to build it in that way.
Yeah, absolutely. I mean, it's a personal preference. I like to be able to drive a car and not be worried about it at that level. But yeah, I mean, obviously everyone is a little bit different. In terms of the billet components that you're adding, like the inlet manifolds, and I mean, obviously it's difficult in the podcast to explain this, and people can jump on your website or follow your Instagram account after this and actually get a sense if they haven't seen an NRE engine before. I mean, it is absolutely a work of art. I'm interested, what was the design process behind some of these? Let's talk about the inlet manifolds for just one example. And in terms of the design, is this a case where you're modeling airflow? Is there any CFD that goes along with this? Or are you sort of working on the basis of form follows function? In other words, if it looks the part, if it looks like it's going to work, it probably will work.
Oh yeah, there's definitely a whole bunch of airflow testing. There's experience from over the years to know what taper angles worked, what runner lengths worked, and then we can go in and model, pressure simulations and all of that stuff. In the end, when you put it on the dyno, the lie detector tells you if it's worth it, or you put it in the car, and sometimes you got winners and sometimes you got losers. Yeah, I think everything plays into that. We're definitely not making an art project. We have experience with making some really high horsepower stuff over the years, and then we take the best parts of those things and put it in and then try to make it look, our own unique NRE way.
Let's talk a little bit more about the engines. I mean, you haven't really aligned yourself solely with one manufacturer, so it's hard to sort of talk in generalities because there are differences across the different brands. But let's just talk maybe a little bit about the LS platform, because it is still such a popular one for hot rodding, for modification. And obviously in stock form, the LS block is alloy, and that works up to a point, and particularly when you start adding boost, there is going to be sort of a limit of how far you can push before you start seeing failures with the likes of the bores, the sleeves. What's sort of a safe limit with the factory block, or do you not even bother going anywhere with stock blocks?
We don't do anything with the factory block anymore. Now, that's not to say that the factory block isn't great, because there's tons of guys out there that are killing it with the factory block. A good buddy of mine, Matt Happel, he's like the king, and Richard Holdner and all those guys. Those guys are all, taking stock blocks and putting 1,000 wheel all the time down with them. But for me, as a engine manufacturer, it makes no sense, because you're going to get this block, which to get an LS block is expensive to get like a core block, and then you're going to sleeve it, and then you don't have the extra head bolt holes, you don't have the priority oil style main system. So it really doesn't make any good business sense for me to try to make engines like that. We don't do a whole ton of NA stuff, even though we've got a lot of NA packages. Probably 80% of the engines we're doing are boosted in some way, and in that we start off with almost all, with the exception of like aluminum counterparts, we use a Dart LS Next when it comes to the LS stuff. And that's because it has 2 extra head bolts, which we actually have them make 3/8 instead of the 8 mil stuff. And then we take all the head studs, we make them 1/2 inch. We run billet steel splayed cap. It's got the priority main, and it's just like, that thing is like we've got a couple LSs that are making 2,500 horse continuous for over a minute on the dyno, and you can never do that with a stock block. You just shred that thing in half.
I think it's important to sort of understand that there's a not insignificant expense in going and adding sleeves to the likes of a factory LS block. So when you factor that cost in, I'm guessing for a little bit more money with that Dart block, I can't compare. Obviously, I don't know what the differences in price are, but as you mentioned, there's a bunch of other then benefits that go over and above even a sleeved LS block. So that's what makes it a no-brainer.
Yeah, for us, there actually isn't a price difference. Like if I have to take a stock LS block and do all of those things to make it right, you can just be into a Dart at the same cost.
Yeah, okay.
And the Dart's way better,
In terms of the block, obviously that's important for the strength and reliability, basically to hold in all of that cylinder pressure. What are the other components that you're sort of putting into the rotating assembly, including crank rods, pistons, etc.?
I mean, we use a I-beam style connecting rod. We use either a billet or a 4340 forged crankshaft, mainly 2618 style forgings on the piston. We use, as far as the head gaskets, depending, like 1500 horse and less, I'll use like the MLX series multi-layer Cometic head gaskets with very smooth surface finishes and a heavy clamp load. And beyond that, then we go in and do like flame hoop and receiver groove with all sorts of special sealants, Inconel material on the valves and manganese guide material. So like every single component is selected for an engine like this. It's not something, there's really nothing stock. I don't think there's one stock component except for the timing damper or something like that. There's not much that's stock in the engine.
Sure. To be expected when you're talking the power levels that you're aiming for. I'm interested with the piston. So obviously you need to make a decision here around compression ratio, which is driven in a big element towards the amount of boost pressure you want to run. Obviously, that's driven by the power target, and also the other factor there to take into account is the fuel that you've got available. So, what's sort of your happy go-to place in terms of compression ratio, and are you varying that compression ratio depending whether you're building an engine for pump gas or a race gas, maybe C16, Q16 for an example, or E85 even?
A very safe compression ratio is like 8.8, but I was on that bandwagon for a long time. But nowadays with E85 and even E98, let's say you're building a screw blower, the screw blower really, it's running out of air pretty quick. So if you're building a screw blower, they actually like a bit of compression, 10-1, even 11-1. If you're on E, you can even go 11-1, and there's an enormous amount of power increase that you can do, and it kind of goes against conventional wisdom because you're thinking, well, it's blown, it should be like 9-1, but you actually can make a tremendous amount of power more by putting some compression in those engines, and it works pretty good. So I think you'll probably start seeing that more with a lot of different builders, is people are going to start running a little more compression on turbocharged stuff.
It does get to be a balancing act with the flex fuel E85 because, as you say, I mean, 11-1 might be absolutely fine on E85, but if you have to get that thing around on pump gas, it's going to be very difficult to get the tune conservative enough, or you're going to be really compromising on the pure pump gas so that you've got the best of the best when you're on E85. Is that something you sort of find as well, or would you compromise the compression ratio on an engine that needs to run on both fuels?
It's a fine line. For example, a motor we just had on the dyno recently, like it had a higher compression ratio, and I just murdered the timing table down to like 12 degrees up to peak torque and was able to sneak some timing in after peak torque. And the thing was just a monster, and it had high compression, and there was no detonation because I'm always data logging, checking knock level and everything. I think things are going to go that direction.
Sure.
I already kind of see it happening because the E is kind of driving it, right? So everybody's running E, but I've been doing tests on gas like 91, and it's still surprisingly, you can get away with more than you think as long as you get in. Like, let's say you do a tug, right? You data log it, you trace it, right? And then you do a tug, you got maybe 19 degrees, right? When you hit the dynos at like 3,000 RPM, tons of load, right? You go back, it's got knock everywhere. Sorry, can I cuss on this thing, or are you going to delete it?
You already have, so no need to stop now. that ship has sailed.
But the thing's just a rattle box. You're going to blow it up, right? And then you can go in and you can put a timing value in there that you think man, this thing is like going to create a ton of heat. It's not what I'm, was taught, but you'll have no KR and the thing still makes decent torque. It may not make the torque that you would if you had E in it or something, but it makes plenty. And then you get up at, above peak torque and the thing just sails. Like, I mean, talking hundreds of horsepower or more. It's kind of eye opening.
Sure. Yeah.
That being said, like in an endurance application, that's probably not the play. But for guys that are like a
hit on the straight
Saturday night special or going down quarter mile or something, it is the play, I think, So
yeah. I just wanted to head back and talk a little bit more about the head gasket. You mentioned there, I think the term you used was fire loop and a receiver groove. There's a number of different terms there. I'm essentially guessing you're talking about a fire ring, maybe in the cylinder head and a receiver groove in the block. So it locks the gasket into that receiver groove? Is that the terminology you're sort of talking there?
So we used to do an O-ring, which is like tempered piano wire, and then we'd file fit that. But you can only stick an O-ring out of the block so far. So if you cut a groove to a 48 thousandths wire, you can only stick it out 10 before the wire pops out of the block, if you understand what I'm saying, right? So a fire ring or a flame hoop or whatever, I call them a flame hoop, and it's 80 thousandths tall, and I could stick it out of the block 20 thousandths. So I put, a flame hoop in the block, I stick the hoop out 20 thou, and then I receiver groove it like 12 in the head, and that thing is just jamming that head gasket into that interlock.
Sure.
And it works pretty well.
I'm assuming you're coupling that with a copper gasket to get that level of deformation?
Yes. Yeah. So we'll use, as a matter of fact, when we do a flame hoop, I'll run a thicker gasket than normal. So we won't just run like a 40 thousandths gasket. I'll run like 50 or 60 and make sure that the piston and the deck height are adjusted for that.
Yeah, there seems to be two schools of thought on the receiver groove and O-ring groove situation. And traditionally, I sort of see, if we look at like the top levels, like top alcohol, top fuel, it tends to be the O-ring in the head and the receiver groove in the block. And to me, that sort of makes sense, because the alloy of the head is obviously a little bit softer and is going to tend to be more prone to deformation. Plus, if you're decking or surfacing the head, obviously, then you have to recut your grooves. You're obviously not finding a problem with that. What was the driver between putting it in the block or the head for you?
Well, putting it in the head allows better serviceability for a drag car, because if you have a problem, you could weld the head. If you got to redeck the block, it's an issue to get all that indicated and recut it. So people don't want to do that. But I've always done it in the block, and knock on wood, I don't even know. Like, we have not blown. Like, we'll take a piston out before we knock that thing out, So it's
Okay.
I'm going to totally jack myself and blow a bunch of head gaskets after this now. But like, we have so little head gasket issues, it's ridiculous.
All right, so in terms of an engine that produces maybe 2,000 horsepower or even 1,500 horsepower for that matter, what sort of maintenance schedule and maintenance items does that engine require? I mean, obviously, we're not expecting 100,000 miles of trouble-free motoring anymore, which maybe some just reading these numbers on the internet may have sort of assumed. So, yeah, what's your take on that? What do these engines require to keep them healthy and running?
I guess you need to explain the difference, right? So we have a crate package that makes 1,500 horsepower that you can drive across the country and have like zero issues with it. But that's because it's on the street. So on the street, like, if you turn that thing up to 1,500 horsepower, it's useless, right? You are not using that unless you've got like, a ton of tire, or, you're actually really, going to Mexico and doing the dance, like you're on 1320 racing or something like that. But if you're driving your hot rod with that kind of power, you squirt it, you get like 8 seconds, 10 seconds at most, and then you're off of it. And those motors that we sell, they run forever. And the valve trains that we've designed for them, like me and Billy Godbold, I got some really trick Spintron lobes that on a hydraulic are stable to like, well, they've been Spintron to 10,000. I've never brought them there, but I'll run them 7,500 with only 380 pounds open pressure and not have any issues. So our spring pressures are so low, like the valve train reliability is so good that these motors, they last. Like I got one guy at 10 years, he's been driving the damn thing,
Oh, okay.
Now it's a different story of like going to Cape Canaveral and running, 2,000 horse for a minute flat. Then you're going to be hurting parts because, you're not going to be doing that bang, 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 bang all the time. Then you're putting strain on the parts. It's hard to design a part to hold that much power. Quarter mile at a time you can get away with for a while, just depending on how much load you're putting on it. So I guess you just have to figure out what is the guy going to be doing. If the guy's going to be at the track all the time, beating it all the time, then his reliability expectations need to be in tune. It's not going to give you 100,000 miles. There's nobody on the earth that's going to give you 100,000 miles for that. So you're going to be doing rebuilds quite often. But if you're just you got your little hot rod and you squirt it here and there and scare yourself and scare your friends, I mean, that thing, other than oil changes and making sure that header bolts are tight and fuel injectors are clean, that thing is going to live a long, long time.
I think it probably comes back to, it is very hard if it's street driven on a straight tire to get that thing to hook up and really take full throttle for extended periods of time like you can at a race event or a drag strip. So that makes perfect sense. Now, obviously, a big aspect of the power, the torque, the boost control, the reliability really comes down to the engine management. And I'm guessing, like I have in my career, it's probably a little shorter than yours, but over 27 years, you've probably seen some pretty dramatic shifts in what's available, the quality of what's available, and therefore what it can do, and that's made a massive difference to the results that we can expect. So I'm interested in terms of the ECUs that are your go-to at the moment for these packages. What are you using?
So like it just depends on the price point. Like our standard crate packages are running Holley EFI, and that seems to work for most people. When we get into an application where we really need to control things at a much finer level, I'll use what's called the company name is Life Racing.
Mm-hmm.
And so that ECU, it'll massage your shoulders while you're driving. I mean, it does things so well, so fast, but the price point is very different than what you're going to get into for a Holley. Like you can get into a Holley at, all in at like $2,500, all in a life unit, you're like 15,000. So you have to decide what it is you want to do with the car. But some things that we've been building into our engine packages that are really nice is we have this thing, it's called a safety package for $550. And so we monitor the oil pressure, we monitor the fuel pressure, water temperature, and then also fuel duty. And so if fuel duty ever spikes, we can cut coils. If water temperature ever gets too hot, we can pull the throttle back because it's electronic throttle. Oil pressure ever goes down, we'll shut the motor off. Different things like that. And I can't tell you how many times the motor usually doesn't break because, if it makes it through the dyno and then everything is good, it's usually a supporting system that kills it. It's usually something happened. They overheated it. They ran it out of fuel. The injectors got dirty. It didn't have enough oil pressure, whatever it may be. So at some point when the system gets really good, I could almost warranty these things just having the safety system being that much in control. But I don't know that the people would like me to control it that much, but I'm really kind of thinking of going down that route because it'll save the motor and put it in limp, and then they'll be pissed because it's in limp, but something else is wrong.
They're probably going to be a lot less pissed than paying for a full overhaul because something stupid went wrong and took out the whole engine, though, right?
I mean, I had a guy, street car, and we had the oil pressure set up to where below 20 pounds, it would shut the motor off. And he called me and he said, the motor keeps shutting off on me. And I'm like, it keeps shutting off. I'm like, really? He's like, yeah, it's shut off a couple times today. And I'm like, well, what are you doing? And he was like on a banked oval, like NASCAR, like racing this thing, and it was a wet sump and it was running it out of oil, and I'm like,
it's not really built for that.
Oh my God, man. Like I just saved you 3 engines with this thing, and he didn't understand he was running out of oil,
Yeah.
so stuff like that, it just makes I get so excited about these little ideas that we come up with, and it turns into saving this guy big money.
Yeah, I think the oil pressure cut, it's something I've been using for a long time, particularly when I was tuning customer engines, because it just takes the responsibility off the driver. I mean, particularly if you don't have some more sophisticated oil pressure monitoring as well. If you've just got the old school oil pressure light, I mean, that's probably what, 15 psi. It's only really designed to be of any use when you start the engine at idle. And if you see that damn light come on at 6,000 RPM and you're already at 15 psi, well, the engine's probably toast anyway. That's if you even see the oil pressure light and get out of it. So having the ECU control all of that so the driver doesn't need to think or worry, it's just a no-brainer as far as I'm concerned. Just coming back to the price points of that Holly versus the Life Racing. And those are very different. I mean, Life Racing, to put it in perspective, is a professional level ECU. You'll see these in the likes of Le Mans prototype cars. So that's the sort of product you're talking about. There's a lot of sophisticated features in those ECUs that sort of are born out of a motorsport program. In terms of the differences from your perspective with the engines you're building and tuning, what is it with the Life Racing that you're taking advantage of that you couldn't do on the Holly?
I think that's just the process. Like what's happening with the processor is happening a lot faster than it is in the Holly. So I think there's like, and this is nothing to take away from Holly, because Holly is bar none unbeatable for the price. Like they are just unbelievable for what you get. But like the lambda feedback, the Holly's fantastic, but the lambda feedback on a life unit is like, it's like second to none. Like we were talking about that oil pressure, like on the Holly, I'll go ahead and say, okay, well, when it reaches 20 pounds, we're cutting it. On the life unit, I'll data log the car driving around, and then I'll plot a curve 15 psi under through the engine RPM. And if it ever drops below 15 psi through its normal operating, not just idle, it'll go into limp mode. So that it just could do a lot more. I don't know. I mean, you are going to get what you pay for, right? I mean, if you're paying 15 grand, you're paying 15 grand for a reason, right? That system was born in a racing circuit. Those guys that are running that, they are not messing around. They got big dollars on the line. If you got some funky stuff going on, it's not going to be acceptable.
Yeah, absolutely.
But that said, there's nothing on the market that, in my mind, for the price point, that could compete with Holly right now.
You've already mentioned that you're using drive-by-wire throttle, which is a pretty mature technology. I know there's a lot of people who still have it in their minds that nothing beats a cable throttle in terms of response, but I'd definitely argue that, and there's a lot of advantages that come with using drive-by-wire in terms of being able to plot the driver's foot pedal position versus the actual throttle plate position, so you can control and manipulate the feel as far as the driver's concerned. The other element when you're talking about something that's producing 1,000, 1,500 plus horsepower with turbochargers is actually getting that power to the road. I mean, hey, sometimes we might not want to. It's cool to do a big smoky burnout, but other times trying to at least control the torque so that we can at least get the majority of it to the road or the racetrack is beneficial. Are you doing anything with boost versus speed, boost versus gear, boost versus throttle position to try and make that torque a little bit more manageable?
Yeah, well, definitely. I mean, and it just depends on what the customer wants, but you can do boost by mile per hour, boost versus engine speed. The Holly at a quarter mile track, they have that like perfect pass, or I forgot what the hell it was called, but you're plotting a drive shaft speed, and then when the drive shaft gets out of plot, then it pulls ignition timing.
Sort of almost like a traction control, but passive, really.
Right. So that's and you can go crazy in like the 1 and 2D tables. You could, this and that and plus this plus that, like you can really start getting nuts and you can tailor it to all sorts of different things. You can have like an adjustable boost that when the ethanol content is there at 20 pounds, and then when there's no ethanol, that number 10 on the dial is only 10 pounds. So it, like right there, my mind is kind of going off in those directions right now. of all these little custom trinkets that you can add to the package that really cool that people don't necessarily know are there, you
Yeah,
know?
absolutely. I mean, I think a lot of that really just comes down to how creative you want to be and how much time you want to spend on developing these aspects. You just mentioned number 10 on the dial, so I take it you're still giving the driver some control as well with a driver boost switch or a multi-position switch.
Yeah, it just depends. Like a lot of our packages, we just give them that little touch screen, has an SD card. The SD card has multiple tunes. They wake up in the morning, they can slam a tune in it depending on what fuel they have in it and how much horsepower they want. That seems to be the easiest, low cost way for the driver to be able to control it.
Sure.
We also have, like 10 pot switches that, change boost and tunes. We've got keyed switches that are like resistance valued. So when you switch the key, it senses the resistance change and it'll change the tune based on that. So again, like I said, we can go crazy
Yeah.
with that kind of stuff. And I'm glad to do it if the customer wants to go there. But a lot of guys are just happy with being able to adjust it. Like on a turbo motor, they're like, "What up, Tom?" A lot of them don't even want gear based or anything that like that. They want their 800 horse tune, they want 1,000 horse tune, they want their kill tune, and we can give them all of that stuff. And it really is just like 20 seconds to download it in the car.
In terms of the tuning, you sort of alluded to the original engine dyno that you had, which was the manual water brake dyno. Am I safe to assume you've since upgraded? What are you using these days?
Still a water brake. It's a DTS, which is, I guess you'd call it Superflow now. We made the brake in that. We blew up the original one so many times. We made the brake in that, and we're in the process of kind of making our own big dyno to hold. Because my dyno gets really angry at like 2,500 horse. It's just starts letting it go. It starts cavitating the water. So we're designing a new brake that'll be in like the 4,000 horse range, and that'll be pretty fun to actually pull 4,000 in like a 600 RPM a second style
Mm.
run. Like that's a hairy little pull right there when you're running 15 seconds at 4,000.
It's a lot. That's a
So,
lot.
but I want to be able to do that in the room.
Okay. In terms of that, you mentioned, I guess, for those who aren't aware, the water brake, that's as its name implies, the brake that actually provides load to the dyno so that the engine just doesn't sort of spin straight up to the limiter. And your original one, you had a knob essentially that controlled the amount of load you were applying. Is that how that worked? Manual control as opposed to a computer controlled dyno?
Correct. It's no different. Like the one that I had originally is not that much different than the one that I have now, except for now I have a servo on the top of the water brake and I have a servo on the bottom, and the computer swings those servos to control the load.
Yeah.
So like before, and then there's no joke, is all it was like a garden valve. I mean, it was a glorified garden valve. Like if you think of a hose as you're turning it on, that's what it
Mm.
was. And I was doing turbo and nitrous stuff back in the day, so I welded like a big eighth pipe to that valve, and I'd swing that thing around trying to grab the motor. When you hit the nitrous, you're sitting there trying to swing the water valve to catch it, and you find out real quick that you're not as fast as the computer is with servo. So
I remember my first experience with a water brake engine dyno, and I was really looking forward to it. I was mapping, I think it was a supercharged Buick V6 marathon jet sprint boat motor, and I was really looking forward to it. I'd come from a hydraulic Dynapack chassis dyno where the control was really, really precise, and this was a manual brake. And I said to the guy operating the dyno, all right, I want to go to this cell here. And so he sort of manipulated the throttle and turned this little knob, and sort of all we did was drew circles around the cell that I was interested in for about 30 or 40 seconds. And I was sort of quickly realized, all right, well, this isn't going to fly. I mean, what it was pretty good for was wide open throttle ramp runs, but that was about where it started and where it finished. So, modern technology with these computer controlled dynos, obviously it's come a huge distance. Have you looked at some of the more modern chassis dynos as well, or does that just not make sense given obviously you are building crate motors that don't necessarily come with a chassis to dyno them in?
Yeah, I think for a while there, I actually was thinking about it because it's pretty safe. You don't have to go out in the street and drive it. But nowadays, like beginning of the year, we're not going to be building more cars. And as far as like modern cars, like we can't touch any of those right now. Like EPA is just that it's got to be like smog exempt for us to work on it. So it really doesn't even have a play for us right now.
I'm interested to dive into that because obviously this is a topic that comes up, and a lot of the shops, particularly in the US, are changing their direction based on the EPA, who have obviously got a fairly strong mandate to sort of crush what's happening in the aftermarket, and whether you like that or you don't, whether you're pro or con, it doesn't really matter because that's the reality we're working with. So you just mentioned smog exempt. So how is there a class of vehicle or engine that the EPA is sort of turn a blind eye to? You can do what you want.
Well, yeah, I mean, and I don't know if it's changed recently because it seems like that whole atmosphere is moving fast. We live in Cali, so like if you breathe wrong, you're illegal. But it was like 74 and older, you didn't have to worry about it. I don't know. It may have changed recently again, but that was the deal.
Okay, so if you're dealing with something older than that, you don't really need to worry about the EPA stepping in and telling you you're doing something illegal.
It's good for us because we really build engines for hot rods. So we're building stuff for like 69 Camaros, 68 Chevelles, 67 Mustang, all the golden era bad dude hot rods. If the guy signs like an exemption that it's going to be a race car only, we'll go ahead and build you something for, a late model, but we're not going to go out of our way to build anything late model just because like the fines they're crazy.
Fair enough. Yeah.
I think my one buddy said he got $11 million fine or something like that. He shut his business down and everything. So
That would probably make most people sit up and take a little bit of notice. Just coming back one step, you mentioned sort of stepping up from a dyno that's currently holding 2,500 horsepower to something capable of 4. And I mean, that's an easy number to say, but actually putting something on that dyno that can really test its capabilities is a different thing altogether. From where you are with your engines that are circa 2,500 horsepower, what are you going to need to change in terms of engine internals, components, and turbocharger systems in order to sort of take it from 2,500 to 4,000?
well, the turbos obviously become larger at that level, and the components not very different, to be honest. I mean, when you're at a 2,500 horse level to a 4,000 horse level, I think aluminum rod, obviously flame hoop, things like that, and you get into like a cast piece. You're not into a cast piece anymore. You're into like a billet part at that level. Like we haven't been able to run it on our dyno. Like our dyno, like we flashed 3,000 a couple times, but half the time, steam's coming out of the back of the dyno. And I haven't seen many dynos that actually can hold it other than like a flash.
Yeah. I mean, you're creating a lot of energy, or trying to consume a lot of energy to hold sort of 4,000 horsepower, of course. So that creates a lot of heat as well.
So I think Moran actually did like a dual land and sea, and he grabbed like 5,500 and did it in a good rate. So he put some time into that. That was really impressive on his dyno. So I had called him and asked him what he had done with that, and he definitely did some homework to get that to work right.
Yeah, it's interesting when the ramp up in terms of engine performance is exceeding the rate at which maybe some of the dyno manufacturers are sort of ramping up their equipment as well. Definitely interesting to see where things go in the next few years. All right, look, Tom, I think we'll move towards wrapping this thing up. I want to respect your time here, and we like to finish all of our podcasts with the same 3 questions we ask all of our guests. The first of those is what's next and in the future for you and NRE? Obviously, you've mentioned you've sort of pulled back on some of these custom builds. So where's the future? What's that hold for you?
I think the future is an affordable product line, because I think a lot of people would like our engines, but maybe can't afford it. So we're really kind of pushing toward, well, if you can't have one of our engines, we'll sell you one of our camshafts. We'll sell you a header kit. We'll sell you, an alien intake. We're casting those right now. We'll sell you some of our turbochargers. So we have like 20 products that are in the works of actually had quite a few of them done for a while, but I'm just trying to figure out how I'm going to release it correctly. So that and more affordable, usable crate packages. That's really where I think our push is going to be, is into the easier to install crate engines that are a little more full featured. Like you're getting a lot. The turnkey is kind of overused, but it's almost turnkey to where all these things are done for you.
Yeah, and I think that the simpler you can make it for the end user, the installer, the better. The more work they've got to do, the more hurdles there are in the way, and the more problems they're going to have. And I mean, I think the other aspect that probably comes with that is the more time you or your staff end up answering technical questions on why something doesn't work the way the customer actually thought. So yeah, that makes a lot of sense to me. Next question, is there any advice that you'd give to a younger version of yourself or some of our younger listeners out there that would help maybe reach where you've got to in your career today faster, potentially maybe avoid some pitfalls that you've seen across your time?
Know your value would be one of them, right? I think there was way too many years that I kind of just hoard out and just did it because I wanted to do it and I wanted to learn. And I kind of paid the customer to do all those what if projects. But I think you should get paid for your value. So if you're starting out, don't just do it, get yourself wrapped up into this monumental project and then have a customer that's not willing to pay what you're worth. I think I think the first 10 years I lost money every year. And I just did it because I didn't care. I loved it. It didn't matter to me that power was getting shut off at my house. None of that mattered. I loved every inch of it. I worked 7 days a week, but I think I would charge more. So I would tell that somebody who's starting out, make sure you got a product that, you're going to give that customer some real value and then charge accordingly.
Yeah, I think again that's really solid advice. It's too easy to undervalue what you're doing, and the problem with that is not only do you end up robbing yourself, it also ends up sort of in a race to zero in terms of the others who are out there in the industry. So I think it is important to know the value of what you're doing and to charge accordingly. That's always difficult to do maybe when you're first getting started and you can't put food on the table. But I think you do set a precedent when you start undervaluing yourself, and that's difficult to come back from. The other thing I think as well is it becomes a bit of a supply and demand issue. I know a lot of shop owners who sort of will gloat to me that they're booked out till the middle of next year.
Yeah.
And my answer is always, well, you need to raise your prices because that's not a sustainable level of backlog that you've got in front of you. You need to be managing that expectation a little bit better. So this is where the sort of the balance of business and entrepreneurial aspect and physically being able to do the job, there's that sort of synergy between the two and getting that right. It's often easier said than done. All right, Tom, last question for today. If people want to follow you and see what you're up to, where are they best to do that?
Currently, we've got an Instagram, Nelson Racing Engines, and a Facebook, at Nelson Racing Engines. My website, nelsonracingengines.com. You can see, a lot of projects, engines that we sell, pricing, breakdowns. And in the future, we shot like 26 episodes for YouTube. And probably within the next 3 or 4 months, we're going to start releasing them. But I'm not going to release any of them until I get at least like 12 fully edited and in the bank. And that way I can release one a week for 26 weeks. But it's going to be pretty fun. We spent a lot of time, shooting these things and like done on like red cameras with master glass lenses and lit correctly. And I think it's going to be cool. It'll be, not only will it be cool to see the projects, but they're shot so beautifully. And we try to put like a learning element in these videos that, it's going to be pretty cool when we relaunch our YouTube.
Excellent. Oh, we'll put some links to the show notes to those accounts, and certainly look forward to seeing your new YouTube series launch, and hopefully look forward to in the not too distant future maybe seeing some 4,000 horsepower dyno pulls as well once we get to that point. Thanks again for your time, Tom. It's been great to get some more insight into NRE and your business philosophy. Thanks for joining us.
All right. Thanks a lot.
If you enjoyed this episode of Tune In with Tom Nelson, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high-quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt anywhere in the world. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Sparky Stav from the UK, who has said, "Caution, will cost you money. This is a great podcast with lots of interesting interviews and insights, but listening to it will give you crazy ideas about your own build and cause you to spend even more." Now, Sparky Stavs also asked a question. He's asked, how do we choose the guests for the show? Do they have to get in touch with us, or do we reach out to them? Good question there, and it is actually a little bit of both. We've been in the automotive industry now for about 20 years, so over that time, we have built up a pretty wide network of what we would consider to be people out there in the industry that are at the top of their game. So obviously we can reach out to those people, and at the same time, as the podcast has grown and built up a bit of an audience, we have started to have people reach out to us to get on the podcast as well. If you get in touch with us with your t-shirt size and shipping details, we'll fire a fresh tee straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.